students, welcome to GMD classes. So in this lectures we will solve some problems on the mapping of functions. So let's consider a simple function. You can see here let functions such that n tends to n. Okay, that is f of x is equal to 2x. This is the questions for all n, for all x belongs to n. This is the x and x belongs to n. We have to show that this function is 1 1 and onto. To show that function जो दिया हुआ है f of x is first is what 1 1 and second is what onto. So we have to show this function, given function is whether 1 1 onto or both. So we know that in the case of 1 1 functions, each elements have different image, यानी कि if different inputs have different outputs. So for the simplicity, have a look. Take this is a 1 1 functions by the graphical approach. This is 1 1 functions. Okay, this is the x and this is y. Suppose two inputs have x1 and this is considered x2. At this point, function is what? F of x1, and this function is what? F of x2. No doubts. So these functions have different, because we provide different input, we must have different outputs. Okay, if we say f of x1 is equal to f of x2, okay, so this can be happen only when x1 is equal to x2 first. So for to determine the function with the 1 1, we can consider these conditions. From the graphical approach, we have to see if this function is equal to this, f of x1 is equal to f of x2, only possible when these can be shifted, whether at x1, x1 can be shifted to x2, that is this points. So we can say f of x1 is equal to f of x2 only when x1 is equal to x2. So first apply these conditions in this function. Suppose this function is given f of x is nothing but twice of x. Okay, so f of x1 nothing but twice of x1 and f of x2 nothing but twice of x2. This function is 1 1, then twice of x1 is equal to twice of x2, that means x1 barabar x2. Yes, this condition satisfied. So we can say this function is 1 1 because each different inputs have different outputs, you can say. So this function is 1 1. For onto, we know that range is equal to codomain of this function, onto function. In the case of onto function, suppose here is given this is the domain and this is a range. So if consider y is equal to twice of x, so we can say x is equal to y by 2. Okay, so for simplicity, we consider x belongs to all natural number, that means 0 natural number, so all natural number, simply say natural number, and y is also that it belongs to natural number. So natural number, counting number, that is same. So if we consider any element from the y, suppose karo y is equal to 1 li. Okay, y is equal to what? 1. If we choose 1, then put the value of 1, x is equal to 1 by 2. We can say 1 by 2 is not a natural number. This is a integers. What? This is a integers. So for the onto functions, we have already discussed sets A, sets B. If we consider each elements of sets B must be connected with at least one elements of sets A. But here is a 1 by 2, and when y considers 1, but in the sets of A 1 2 3 4 5, this is the natural sets, natural numbers. 1 by 2 doesn't exist in this range. So when we choose y is equal to 1, it gives the image pre-image 1 by 2, but 1 by 2 doesn't belong to this element. So we can say this is not onto functions because we have considered y is equal to 1. It gives x is equal to 1 by 2, which is invalid. This is not a natural number. X must be a natural number so that we can say this is onto function. But in this case, when y is equal to 1, this is a natural numbers, and natural numbers must gives the output natural numbers. But when we put the y is equal to 1, this gives x is equal to 1 by 2. It is not a natural number, so this doesn't belong to this sets element. So this is not a onto function. Okay, so this function is 1 1, okay, but not onto functions. So 1 1 hai, but onto function is not. Okay, so let's have another examples. You can consider, suppose